Hello, everyone, and welcome to our webinar today, Enterprise-Grade Data Security for PostgreSQL. We're about to get started, and just before we do, just wanted to go over a quick platform and housekeeping items. First of all, yes, the webinar is being recorded, and we will send you a link for the recording in email after the webinar is over. The webinar is also meant to be quite interactive, so throughout the session today, you will see some things where you will have a chance to interact with us. First of all, you can ask questions at any time using the questions little button at the bottom right corner there, and we'll answer all of the questions at the end of the webinar. But please feel free to submit your questions throughout. Second, we're also going to be starting using some interactive polls. So you will see the polls pop up on your screen, and please take a few seconds to answer them. And with that, we are ready to get started. I would like to turn things over to your host, Sushant Rao. Sushant, all yours.
Great. Thank you so much, Hormaz. Hello, everyone. So I'll be your moderator for today. And before we really start getting into the content, we'd like to do a quick poll and see kind of how you are using Postgres today. Hormaz, would you mind pushing the poll? There we go. So this is a multi-select. How are you using Postgres today? Have you deployed it on premises, deployed software in your cloud VPC, you're using Amazon RDS and or Aurora, you're using a different Postgres cloud service or other, and if it's other, please describe in the chat. So go ahead and submit your vote, and we can take a quick look to see what everyone's using. So it looks like there's some people across the variety. People have deployed it on premises using Amazon and Aurora is probably the biggest one. Some people are using a different Postgres cloud service, and we do have other folks who are doing it as other. So if you can, please put it in the chat so we understand how you're using it. So let's move on. And I'd like to now introduce our speakers. So first up is Chirag. Chirag, would you mind introducing yourself?
Hello, and thanks for joining us here. My name is Chirag Dave. I'm a Principal Database Specialist SA here at AWS. I've been with AWS for a little over 3 years. As I mentioned, I'm a Postgres specialist, and I've been around Postgres technology and ecosystem for a little over 15 years, and I'm excited to do this presentation today. Anank?
Thank you, Chirag. Hi there, everyone. My name is Min Ko. I head up product here at Baffle. Prior to joining Baffle, I spent about 15 years leading development of database security features at Oracle.
Great. So with that, let me turn it over to Chirag and start off with talking about Postgres.
All right, so let's get started. So let's start with what is Postgres. So those of you who don't know, Postgres is a open source relational database system. And if you look at the history of Postgres, Postgres was actually a project at UC Berkeley back in 1986. And it was then open source, I believe, sometime in 96. So the project has been around for a long time and has been open source. And on the right side, you see that Postgres was a DBMS of the year 2023, and there are good reasons behind this because we see a lot of migration that happens from a commercial database to Postgres because of its feature compatibility with some of the other commercial databases. So one of the key things about Postgres is it's very developer friendly. So there are many features which are geared towards developer, and also one of the core tenets for the Postgres project is that to provide you with the data integrity, so your developer and your architect can build a fault-tolerant environment. So those are the core principles of Postgres. And the way Postgres works is there's not a single owner for the Postgres. Postgres development works as a community. There is a global development group which focuses on the core database aspect of it, the engine part of it, the parser or the query tuning, the query analyzers, or the core Postgres feature they work on. But one of the greatest power of Postgres is that it's highly extensible, right? So while we have certain core features in Postgres, it is open to be extended. What does that mean? meaning that if you require a certain feature which are not in the core, you can add features on top of it by creating an extension. And we'll talk more about it, and we'll circle back to this point again. So real quick comparison of database security capability, and this is, I think, the theme of our talk, and we'll come back to it, that, natively Postgres supports row-level security, and here with RDS and Aurora, we do encrypt your data. We do encrypt your data in transit and at rest, and we do provide you with a various way to integrate as far as your authentication goes, the IAM authentication, or if you want to do a Kerberos authentication. But there are some features that are available in the commercial, like Oracle and SQL Server. As you can see, they're lacking in Postgres, and that's where we're going to see how Postgres extension and Baffle can help. So now, as we're talking about extension, let's just dive a little bit and talk about what is extension. As I mentioned, it's just a package containing new functionality on top of the Postgres. And if you are working in Postgres landscape, the ecosystem has over thousands of open source and commercial extension available. And here at AWS, both in RDS and Aurora, we support 90 plus extension, and we grow. So there are very common extension you might be familiar with, like pgstat statement or PostGIS or pgpartment, and the list goes on. And we support that. So once you're running an RDS Aurora, those extensions are available for you, ready to use. So Postgres extension, as I said, it's great. It sounds like, okay, you have the core functionality, which is pretty solid in Postgres, but now you can even extend it. But before we get into some of the challenges, let's look at some of the examples of the extensions, right? So for example, there are extensions available that if you want to improve, let's say, a bitmap compression, you want to do some data processing, so you can write your own custom functions, extend your SQL, and improve your app performance. One of my favorite extension is, let's say, you can create more data types. For example, if you want to store geospatial information, then Postgres has a very popular extension called PostGIS, which helps you to store your GIS data. Vector data is another great example for extending data types. So whereas Postgres does support standard SQL data types, but if you want, you can create new data type, you can create new function, you can create new operators, and that opens up a lot more opportunities for you. On the foreign data wrapper side of things, let's say if you're sharding your database or you're federating your database, or you might have a case where you're running Postgres, but you want to get some data from Oracle. Postgres does support something called as FDW, or foreign data wrapper. So you can have your Postgres connect to Oracle and get the data from or SQL or MySQL, or Postgres to Postgres for that matter. So again, a great use case for these extensions, which are not available in core, but easily can be extended. Then comes the last one, is the management and monitoring, right? So maybe you want to monitor the performance, or you want to audit your queries or your query execution. One such great example is in Aurora Postgres, we have an extension called QPM, or Query Plan Management. So this is an extension that we wrote to support a query plan management, meaning if you want your query plan to be stabilized between version, if the plan changes, you might have a performance regression. So with this extension, you can say, okay, here's the plan A, which I like it. I want to use this plan regardless of other plans. The Postgres will decide. So it's a great way to stabilize your performance. So again, that's thanks to extension, we could do this. So I've said enough about extension, and it's great, but there are traditional challenges when it comes to extension. And let's talk about what are these challenges. So most extensions are written in C, and C language have been involved in some risk of unsafe database access. And this can be mitigated by how you manage and deploy this extension. For example, extension could require access to a file system. It could require access to your shared memory. It could require some privileged access or access to a network. At AWS, we support, as I mentioned, 90 plus extension, and under shared responsibility model, we go through and we're responsible for all the infrastructure security for this extension. And it takes time to validate and making sure all extensions are safe. Other things with the extension is extensions are not universally available, or every time you write extension, the upgrade of extension can be a challenge. Extension needs to be certified by DBAs before you roll it into productions. And at AWS, we've heard, we support 90 plus extension, but customer keep asking us for a new extension that, hey, I've written this extension. I want this to be supported in RDS. This is how I ran it in my self-managed. I want this to be running on RDS. And for us, because of the security is our priority, it takes time. And this is where we thought that, hey, it is the time to innovate and create a model to manage and deploy extension in a safe manner. So let's do a quick poll before we get in. I want to talk about something that we worked on is the trusted language extension. And a quick poll here is that, have you heard about TLE or trusted language extension for Postgres before today? I appreciate your input here. Do you have any reaction, Sushant, or move on? Just trying to get the gauge here.
I mean, it looks like some people have heard of it, but a fair amount haven't. So
Okay,
I think it's a good mix.
All right. So again, what we talked about is Postgres is awesome. Extension make it even more awesome, but there are challenges with extension and because of the security. And now let's talk about TLE. So TLE is a trusted language extension for Postgres. So we talked about extension, but then there are trusted languages like PL Rust, JavaScript, Perl, PL PGSQL. Why we call it trusted language? Because these languages have some built-in guardrail for the safety. And now what we're doing is combining these two. What we've done with TLE is we have created an extension. It is an open source kit or open source project. It's available in GitHub. And with this, you as a developer can create extension on your own using one of these preferred language or the trusted language. So now we got best of the both world. Now, once this TLE extension is installed, so first thing you have to do is install the TLE extension. Once the extension is installed, you can write your own extension and use this extension in RDS or Postgres in a safe manner, right? So again, this was our way to innovate and provide a developer to write more extension and be able to use this in RDS or Postgres. Let's look at how it works. So again, very simple flow. You have and again, first, this TLE is available on certain versions, so Postgres 14 and 14.5 and higher. And the flow typically will look like you as a builder will have this framework, and they will write a code and create an extension. And you as a customer then can choose this extension and have this extension installed by your DBA. Once that extension is created, it's highly portable. Now, let's look at what are the typical use cases, where we see a lot of use cases of extension. There are some examples I want to talk about. So as we mentioned in Postgres, let's say, this is what a very typical ask for us been for a while that, hey, I'm coming from Oracle, and Oracle does provides us to check the strength of the password. Well, Postgres natively does not have that. Or when my user logs in, and if n number of bad password, I want you to lock it. It's not really supported. But Postgres, besides extension, has a feature called hooks. Hooks are nothing but you have a code path, and you could expose this hook to do something else, or can extend it. So now what you can do is you can write an extension to check the password strength, or how strong your password is. Or if I'm logging in and if I have a bad password, I can use that hook and you create an extension to act upon it. And you will see that in a demo in just a minute here. So the other ones is custom data types, as I mentioned. One of them I already mentioned earlier with PostGIS, another extension that you create a custom data type. Or there are any other unsupported extension, you can bring it in RDS with a TLE. And last but not least, and that's where the core of this talk is going to go, is you can write an extension to do an advanced encryption function right within the Postgres, and that's what Baffle and Ming will talk about. So before I move on, let me just show you a quick demo about how do you get started. My first demo, I have two demos actually. So the first one I want to show is, again, like I said, natively Postgres does not have ways to block the user if they type in password n number of times. In my case, it's 5 times, right? So I want to show you how do you write an extension and how do you implement that. And the second extension I want to talk about is to show you how do you create UID7. So UID is a random number, but UID7 has a peculiar characteristics where it's sortable, right? So a lot of Postgres use case makes sense to use UID7, especially if you're indexing on UID7. Your B-tree index will be much more right-leaning and you get better performance with UID7. So a lot of customers ask us, hey, we need UID7, but hey, now you can install pgtle and create an extension to create UID7. And just by writing a simple function, you can generate UID7 right within Postgres using a trusted language and powerful language like Rust. And I'll show that in the demo here. So allow me to quickly share my demo, and then we'll proceed. All right. Okay. Okay, so my first demo, as I said, how do you get started? I have a Postgres database, happens to be on version 16.2. And what I'm first doing is I'm looking at my shared preload library. So this is a standard way of installing any extension. This is typically in RDS done through a parameter group. So in the parameter group, you would say, I want to install pgtle. And because I'm doing a client auth, I need to enable a couple other parameters in parameter group, which is I want to enable the client auth and for my database Postgres. And I have this user, TLE user, which I'm using, which I want to make sure that if there are bad password, I want to lock that user. So that's the baseline of it. Next thing, what we want to do is we want to create this extension, right? So first thing, again, like I said, TLE is a framework. So first you install TLE, and then you write a new extension on top of it. So right now I'm just creating a TLE or creating a framework. Next thing I want to do is actually write a function which is doing the password check and if it's failed. So it's overwhelming on the screen, but let me kind of break it down, right? So this extension is written in PL/PGSQL. We can write it in any other safe language. All I'm doing here is that, it says, okay, here's a version. What is it doing? And I have a table, right, with the username and how many times they attempted. And this is where I'm exploiting the Postgres hook. So Postgres is a hook for the client auth. And all am I doing here is that anytime a user is logging in, I'm counting how many times there were failed attempts. And every time there's a failed attempt, I insert this data into my failed attempt table that was created. And if after 4th time, let's say customer chooses the right password, we kind of update that one as well. So and then there is a function to reset it. This sample code is available on our GitHub samples, and I think we'll be blogging about it as well, or maybe I already blogged about it. But that's the idea that, very easily you could write a extension with some PL/PGSQL code. And once that extension is created, you have to actually create an extension, right? So this is the last part where I said create extension client lockout. Once that's done, now we can test if our extension works. So next thing what I'm doing here is that I'm trying to connect to my database. And this time I'm going to be trying the password incorrectly for 5 times, and let's see what happens, right? As expected, we would see some lockout messages after the 5th time. So I'm connecting to my Postgres database, and I'm using my PGTLE user. That's what I'm asking Postgres to enforce. In uppercase W, those of you who don't know, it asks you, prompt you for the password. And I type in the wrong password, I get password authentication. This is a pretty standard Postgres thing. Try this twice, thrice, and every time I try, it's failing on password authentication, as you expect. Now, this is the 5th time all these authentication has failed. Now, interesting thing is, how does Postgres or extension is handling this on the 6th try, right? So on the 6th try, when I try it, it's gonna kick in that hook, and it'll say the message saying PGTL user has failed more than 5 times. Please contact your database. So these are some of the features that you might be familiar with the Oracle. So now with the extension, you can build this into your system, right? That's simple PL/PG/SQL. So that's number one. The second demo that I want to show is around UID7. So like I said, PGTLE is a open source project. You can go to GitHub and do a checkout, and that's what I've done. And there are a bunch of examples as well. As you can see, it has examples. And one of the examples I want to show today is UID7, because it's pretty cool extension written in PL Rust. It's very powerful, performant, and let's see how that works, right? So a lot of these examples come with a make file. So your installation becomes very easy. All you have to do is make install. It installs the required SQL for my extension. Remember, these are the first step that you do to create extension or to install the extension, but then you have to actually go ahead and create this extension. Now, remember I said this extension was written in PL Rust, so you need to create a Rust. So there are a few things that I'll do here. This is a handy function that you see. It shows you what are the extensions that were installed using TLE. So I can see client lockout was installed, and now I've installed UID7. So the next thing that I'm doing is I'm creating a PL Rust extension and then actual UID v7 extension. Once that's done, because this extension provides with this function called generate UID v7, all I have to do is select this function and I get a random UID. So the point I'm trying to drive here is that, so 2 examples we saw. One is the client lockout, which we use extension and the hooks in the Postgres to let Postgres code path take different path to do something different, right? So normal operation for Postgres is Postgres will constantly say if it's a wrong password, it'll keep complaining about wrong password. But now we have changed the code path by writing an extension. You want to do something different after a 5th consecutive login fail. You want to lock the user. And that's what we have done. The second example is a good example where we've written this extension, and you could see this extension available on the example that how we have used the PL Rust to write this function UID v7. So you get an idea here now that with the framework TLE, it becomes so powerful to extend your databases. Let me pass on to Ming to talk more about Baffle and how Baffle have created extension using Rust for advanced encryption function. So let me go ahead and stop share here. And Minhang, take it over, please.
Thank you, Sharok. As you can imagine, we here at Baffle are super excited about the availability of TLE on AWS, RDS, and Aurora, because it allows us to do so much in terms of enabling data security for PostgreSQL on Amazon. But before we get too deep into how it works, I thought it may be worthwhile to take a step back to discuss sort of the motivating factors behind data security and why it matters. And for any of us who've interacted with compliance or InfoSec in our respective companies, we know that at the end of the day, one of the things that really drive the need for data security is meeting compliance requirements. And there are many, many out there, right? I think I saw a stat a while back: 71% of people are covered by compliance, or 71% of countries out there in the world are covered by compliance requirement. And this is internationally. Obviously, U.S., Europe, lots of compliance requirements. We don't all need to go into the every line or every sort of section of these laws and regulations. I tried to sort of summarize it so that we all kind of can appreciate ultimately what these data privacy and data security compliance requirements are really aiming to do. And if I were to really simplify in a nutshell, I really just ask everyone who actually owns sensitive data or private data to actually have control over it. And by control, it just doesn't mean that you can actually access it and you can sort of see it. It really is about proving that only the people who need to see it can see it, and the people who don't need to see it cannot see it. I know it seems like a very simple concept, but if you think about all the people who might inadvertently or perhaps shouldn't have access to all that data, you'd be surprised. Just think about your company. You'll realize that actually, yeah, that quite more often than not, you have access to more than you need, or someone in the company has more access than what you need, and that's why data security measures are in place. And really, these compliance requirements are not just created to be, I guess, for no reason, right? There are a lot of issues that have led them to become to the forefront. Even in 2023, after decades of IT systems being in place and data security measures being put in, we're still seeing growth in data breaches. It's unfortunate. It's kind of become a fact of life, and it's something that is not sustainable if we don't put them in check. And these data breaches are not, victimless. There are costs to them. The companies that actually suffer data breaches, obviously have to incur both a financial cost, whether it be in terms of trying to remediate, all those credit monitoring, all those other additional work they have to do forensics. Obviously, there's also reputational costs to them. So that's data breaches inevitably will hurt the financials of the business. Top of mind recently, I don't know if any of you heard about United Healthcare having testified in front of Congress. So they were extorted 22 million right out of the gate. And in the end, what happened? Well, the data still got exposed on the dark web anyway. So the reality is that data breaches hurt company financials, and they obviously need to do what they can to address them. So you would think, as I said, it be IT systems and databases being decades old, that this should be a solved problem, right? And to a certain extent it is. There have been a multitude of security features and capabilities that have been put in to databases even since the early days in an effort to at least stem the flow, so address the vulnerabilities or potential vulnerability and potential risks, right? Databases like Oracle and SQL Server have had a multitude of features governing access control, governing the encryption of data, governing with respect to masking. They have all basically at least helped address some of the risk, and if essentially had been sort of enshrined in a lot of compliance requirements. They're not necessarily explicitly stated in the regulations, but most of the internal and external auditors will generally check for this type of control to make sure that you have them as a way of knowing that at least you did your due diligence in terms of your database security. As you can imagine, these legacy databases had a bit of a head start, and Postgres being sort of more of a community, PostgreSQL being more of a community-driven effort, has been a little bit lagging in this respect. The thing is that with the legacy databases, a lot of these features were built for a different time and for a different set of risks and threat. A new set of risks and threat have come along, with the migration to cloud, with the use of SaaS, and additional security features are needed to address those. And even there, the legacy databases are behind. So, they made some headway into trying to deal with those particular requirements. But yeah, I mean, in that respect, all the databases essentially are sort of lacking in terms of security measures to deal with those things. And this is where Baffle can really help. So what Baffle offers is a comprehensive set of data security features that actually ensures security of your data in your relational database, PostgreSQL, for example, such that you actually cover both all the legacy capabilities. You have basically all the same controls, if not better, than what you would have had on Oracle, SQL Server, and other databases, but also new capabilities that address current and sort of more modern threats. So this essentially will put you in a security posture that's ahead of the curve as far as dealing with compliance and risk is concerned. So, at this point in time, I just want to check maybe to see for those of you in the audience whether or not do a quick poll to see whether or not you're using any of these security features. So specifically, are you currently using any any of the security features listed here with the legacy that is non-PostgreSQL databases? Say yes if you are, or if you aren't using one of the legacy databases, feel free to say no as well. Let's give everybody a moment there and see. Okay, so what I'm seeing is about 2/3 of the folks in this webinar actually using some of the legacy features. So yeah, so you would appreciate the fact that there's a set of controls that you would have, and that if you're considering PostgreSQL in terms of moving any of the data or any of the application workloads from those legacy databases to PostgreSQL, that you want to have equivalent controls, or you essentially shifted your security posture, or at least weakened your security posture with respect to your data. All right, so then I've talked a lot about how Baffle covers the full gamut of data security capabilities. I just want to dive in a little bit about how we do it. And the way that we do it, I like to sort of, again, simplify to our sort of unique architecture of having a proxy and an extension. So let me explain what each of these pieces do. The proxy is something that Baffle offers that sits in between the application and database. And essentially, as sort of this service in the middle, it actually intercepts all the communication between the application and database such that as the data flows into the database, we can ensure that it's encrypted or masked or tokenized so that it never actually reaches the database in clear text. And also being in that position, it's actually able to monitor and sort of and log and make sure, get a full view of everything that's happening between the application and database. The extension, on the other hand, is something that we plug into the database itself. And as mentioned, we're super excited about the fact that Trusted Language Extension is available on Aurora RDS, because we can now plug our extension into AWS Managed Database Service. And what this extension does essentially is introduce a new data type and a set of user-defined functions for that data type. The data type is just to represent the encrypted data, and the functions will allow you to actually operate on that encrypted data. And as Chirag alluded to earlier, there's PL Rust support on AWS RDS, which is extremely helpful because what we found in our personal experience is that when we first started implementing these extensions, we did it in C for the best possible performance, and we're able to do the same thing in PL Rust and actually achieve comparable performance. So it was great for us, and to sort of share how much of a lead AWS has in this respect, right? There's no other. We are not able to do this with any other managed database provider today. Only AWS has this capability. So the proxy extension architecture is unique to Baffle, and because we have this, we can actually cover, as I said, the full gamut, right? I already alluded to earlier, when data comes in, we are now able to protect, encrypt, and mask, and you can do this without any code changes. Some of you may already be familiar with the concept of application encryption. That's when you modify your application code so that you encrypt the data before it goes to the database. It's great in terms of ensuring security posture. It's horrible in terms of having to essentially change application code, manage an entire application lifecycle to do it. The proxy takes away all of that pain. And because the data never reaches the database in clear text, privileged users of the database can never access this data. Remember earlier when I talked about compliance requirements and how one of the key tenets of compliance is really just ensuring that people who don't need to know shouldn't know sensitive data values? Well, the classic example is privileged user of a database, namely, say, your database administrator. They need to be able to do operational things like backup, replication, HA, you name it, but they really don't need to know your address, your phone number, your credit card number. But they still do because the access control mechanisms of databases simply doesn't allow for that level of separation. With Baffle, you can get that. And as mentioned earlier, the cool thing about the extension is that it's actually able to process the encrypted data values, even though it never actually arrives in the database in clear text. So that allows all the operations that your application will ever execute on a database to function normally. And of course, being right in the middle of that communication, the Baffle Shield proxy is able to also transform the data on its presentation back to the application. So in other words, it can mask values. A typical example would be if you ever need to just show only the last 4 digits of a social security number or credit card number. And it can even enforce sort of a limit rows or specific pieces of information that the application returned to end users. Another thing unique to our architecture and what Babel can do is that not only can we actually control access to data so at a row level, we could also segment it by tenants. And let me take a step back to explain this. So say you have a SaaS application and you're serving multiple business customers out there. Quite often, most of those customers would like their data to be segregated from each other, even though your SaaS application may actually commingle them in the database. With Baffle, what we can do is actually allow you to give each one of those tenants their own crypto keys. And those crypto keys can actually be stored in their own key store. So imagine different KMS accounts, or if they actually prefer something even higher security, their own HSMs. And essentially, we can then make sure that all the tenants' data is encrypted by their own respective key. That way, they're absolutely certain that their data is never somehow exposed. And if when they leave, they could just delete those keys, just make sure that data is shredded. And as mentioned earlier in the table, another capability, just because of the way the architecture is set up, we're actually able to enforce role-based access control, which databases have in general, but we could actually enforce it based on roles in identity management providers. And this is a particularly useful feature for enterprises because a lot of times they don't want to have to manage roles in separate systems, and that's kind of the main purpose of IDMs, right? You want to find your group for all your users and all your employees and make sure you assign roles in one place, and we can facilitate that. Lastly, but certainly not least, we have a user interface that actually allows you to be able to see the policies and see all the information that's collected from monitoring and logging so that you could actually report it for auditing and compliance, right? Remember, a big driver of data security is to ensure that you're compliant. And oftentimes, the way to prove that you're compliant is to auditors. And having it all in one place for your audits simplifies that process so much more. Right, so I spoke really fast because I'll be respect for everybody's time, but a lot of times it's a lot easier just to show rather than tell. So what I'm going to do is just do a quick demo about a key aspect of what I just described, which is comparing the legacy database capability with what Baffle can do. And I'm going to give me a second there just to share screen. Oh, all right, let me move this out of the way. This happens Hopefully people can see MySQL Workbench and the pgadmin screen. So Sean, if you don't mind, give me
Yeah, looks good.
confirmation. Okay, cool. Thank you. All right. So first thing I'm going to show is something seemingly trivial, but this is the state of the world today. This is a MySQL database I've set up that's currently using transparent data encryption. This is kind of the standard database encryption mechanisms that would check the box in legacy compliance audits. So what I have here is I'm logged in as a root user, and I've created a table called transactions table. If you just take a quick look at it, nothing particularly fancy, some credit card numbers, some names. And just to do a quick sanity check, I do in fact have encryption enabled. So for those of you who answered in the poll earlier that you're using legacy features, there's a good chance that you might be using transparent data encryption in Oracle or SQL Server. MySQL also has implemented, and they all generally operate the same way. So I'm going to show you what transparent encryption generally does. I'm going to do a query against that table that I just showed. And as you can see, one of its strengths is that it's transparent, right? I can query that table and I can see the data. You can picture the application creating that table and be able to interact with the data essentially seamlessly. There is, however, a problem that is implied here, and perhaps too many people just kind of brush past it, which is I'm the DBA, I'm the root user here, and I can see the email addresses, name, basically all the sensitive information. So what all transparent data encryption got me was essentially encrypting the data on the file system somewhere. So that one, you can either pass the audit, or two, if someone steals the disk, they can actually ensure that's protected. And again, this actually made a lot of sense back in the on-prem days when everybody maintained their own data center. So there's a reason why this was built, but it is not really built for the risk of modern time. Now, what I'm going to do is I'm going to now go over here to put a pgadmin connection to Baffle proxy. It's the same table, obviously different databases. And right now I'm just logged in as someone that's called the app user. So imagine your typical application. And there's no described table. Instead, the equivalent is this query here. As you can see, same table, same columns. And what I'm going to do here is I'm going to execute the same query. Oh, okay. Well, again, clear text data. So, this seems to be pretty transparent as well. So as the application, I should be able to execute my queries against the database, in this case through the Baffle shell proxy, and achieve transparency. Now the key difference here, and I'm going to demonstrate this through another terminal so that's a little bit more clear, is let's say that I'm the DBA now. So the application should have access to data. We all agree with that. But the DBA should not have access to data. So I'm just going to log in directly to that same database. If I don't at least get one bad password error, that means that it's not alive, right? Okay, so I logged into that database and we'll execute that select star query again. And this is actually the view for the DBA. In this particular case, I've encrypted name. I've left email alone so they can kind of compare the rows here. Oops, over here. So you can see the rows are matching, but some of the values I've chosen to encrypt are now fully encrypted. Obviously, I want to encrypt credit card. So you can see the big difference now, right? Baffle is built for modern time. It's designed to limit access control to only those who need to have it. And you can actually see the encryption working. And just again, to demonstrate sort of the equivalent transparency. Again, on the TDE side, what I'm going to do is execute a query. Here I'm doing an average of transaction quantity from the table with a search, with a like search, right? This is not necessarily atypical, but it definitely demonstrates the fact that I'm trying to process the encrypted data. And again, TDE's strength is that it is transparent. It's able to execute that flawlessly, even though the underlying table is encrypted. The cool thing about Baffle is that we can do that as well. So I'm going to execute the exact same query. As you can see, we maintain what Baffle has done is maintain the same level of transparency, except giving you true control over your data. All right, with that short demo, I think we're getting close to the top of the hour, so I'll turn it over back to Sushant.
Great. Thank you, Minhank. So let's kind of wrap up here. What should you take away from this, right? So the first is, to meet modern compliance requirements, you require enterprise-grade data security from your database. This is one of the reasons why companies feel like they're stuck on Oracle and Microsoft SQL Server, because they have those capabilities. And one of the things you should understand is with Baffle, working with AWS, technically Amazon RDS and Aurora, and their trusted language extensions, we can now provide the same capabilities that you would expect from legacy database services. And as Minhank showed, you're actually now set up to the current state of the art when it comes to data security. So this is the key takeaway. I think it's pretty important and gives you a lot more flexibility and options when you're thinking about setting up a new application with a database, or if you have an existing application that's running on Oracle or SQL Server and you would like to use Postgres, you now have an option that gives you not only all the capabilities that they have, but even more. So next steps before we hit QA. Try Baffle for Amazon Aurora and RDS for yourself. If you have a phone, you can pull out that QR code, or just go to baffle.io/request-a-demo Postgres, and you'll get to the meeting page. You'll meet with a Baffle security expert to discuss your data security concerns, verify Baffle's capabilities, meet your needs, and get access to Baffle. It's pretty simple. So now let's go through Q&A. I see that some people have already submitted some questions, so let's address them. What do I need to do to use TLE with RDS or Aurora? Chirag, I think that's for you. And you may want to, there you go.
Yeah, so again, very straightforward. Make sure you're the right version that supports TLE. So that's number one. And number two, you just have to select the right parameter group. Parameter groups are nothing but the configuration for the database. As I showed in my demo, in your shared preload library, you set TLE, pgTLE as one of the shared preload library. Restart your database. And then once you create the extension pgTLE, you're off the races. At that point, you have the baseline to start creating your own extension. So fairly straightforward. There's a lot of documentation on our public website and also the GitHub project, that is.
Awesome. Let's see. Oh, Minhank, this I think goes well with the previous question. How do I deploy Baffle with RDS or Aurora? What do they need to do?
Yeah, and I probably should have covered that a little earlier. So with Baffle, as I mentioned, there's a proxy and there's a extension portion. With a proxy, that's basically containerized software that you would deploy. It's your choice whether you want to just do it on Docker, or we typically recommend customers deploy in a Kubernetes cluster so that it scales with your need. The extension actually deploys just like the way Chirag shows it. After you have TLE and then Rust install, you would just basically run our extension install, and that's it.
All right. Sure, here's a question for you. Someone's asking, what other Postgres cloud services have TLE?
Yeah, so currently, while it is open source, currently it's only supported by AWS. But again, just want to emphasize that is an open source. If you want to extend the TLE further, we're open to take PR, and you can always patch it. So if to answer your question, it's currently only supported in AWS.
Hank, here's a question from you. What key stores are supported by Baffle?
We support AWS KMS. We support Azure obviously all the other cloud provider equivalents. We also support HashiVault. If you have a KMIP server, and there's a bunch of key management providers that fall under that category will support those as well.
And then here's another one. Because we said Baffle sits in the data path, someone is asking about the performance overhead by the proxy and the extension compared to vanilla.
Yeah, I mean, I always want to be able to just give one number, but that would be unrealistic, right? It is going to be workload dependent. What I can give you a sense of is that the performance overhead is actually just going to be roughly the cost of the network latency plus the encrypt-decrypt cost for the most part. And if you have to do encryption, you're pretty much going to have to absorb those costs anyway. From what we can tell, actually, most of our customers essentially have seen no impact on their end user response time. So my suggestion is actually try it out, get a sense of how it performs your workload. What I've also found is that because we're deployed, containerized in a scalable way, we're pretty much almost always able to meet the SLA that you would need for your application, just simply by addressing it through the proper scaling.
Awesome. It is one of the secrets of database benchmarking is everyone can have good numbers, but your mileage may vary. So I think that is wise advice to try it for yourself. And I think we have one last question. Minhanky, it says, what regulations will Baffle not cover? I think the question comes from, how do you make sure what Baffle will and will not cover when it comes to the privacy regulations?
Yeah, I mean, in terms of data privacy regulations, Baffle will pretty much at least address the critical aspect of it. Remember, the data privacy regulation is really focused on control, right? And there's no better control in making sure that default state of your data is encrypted. What Baffle does is make sure that encryption is happening at a very granular field level. So, TDE and other forms of encryption, you almost requires you to decrypt the whole disk or decrypt the whole database in order to actually access a piece of data. That doesn't give you any control because you open the gates every time someone wants to access something. Here, the control is at every single value. If you want to give someone a social security number, you do that. And because of that, that's how we could confidently say that, yes, we're going to be able to help you address the control aspect of every data privacy requirement.
All right. So it looks like we've covered all the questions. Let me now, and we're getting close to time, so let me turn it over to Hermas for a final wrap-up.
Well, thank you, Sushant, and thank you, Chirag and Minhang, for sharing your expertise. And of course, thank you to our audience for joining us today and for making this interactive. We hope you will join us again next time. As mentioned earlier, you will get an email with a link to the recording of the webinar, so you can view it later, as well as share it with your colleagues. That brings our session today to a close. Thank you, everybody, and hope you have a good day. Bye.
Thanks, everyone.
Thank you.